I think I asked the last question about SPM on purpose because, of course, it's our next topic. And to tell you more about that, please welcome Zouhair.
Everyone. Well, I hope you're doing okay. I'm a bit stressed, but I'm really happy to be here. And I want to start by thanking the people at FrenchKit for having me here and letting me talk to you a bit about how you can use local packages to modularize your code base and try and modernize it. And the second thing I want to say before I start is I'm going to show you some weird stuff. As in, I'm going to show you some Objective-C code, and I'm really sorry about it. I'm going to show you a project that looks like what we had at Medium, I'd say 2 years ago or something. And I'm also going to show you some ways to make it better that might not be the way you would do it. But I'd like you to keep an open mind and look more at the approach and the strategies and see how maybe these could help you, and maybe some hints and tips that I'm going to unveil might be of some help. All right, cool. We're going to start. So why would you modernize a code base? That's a simple one. The why is easy. You want to make it more robust. You want to make future changes faster and easier to implement. And one thing that's really important when you work on a team is you want to make it easier for collaboration. You want to facilitate that. And modularizing it, as we'll see, really helps this because you're going to put things into little modules. They're going to be independent. And maybe one of you is going to use the module, and maybe another one is going to work on the innards of the module, but you won't conflict all the time. And then the other question is, when do you modernize a code base? And I don't know, maybe you thought about going to the big wigs at your company and telling them, OK, you want me to implement all of these new features and solve all of these things, but the code base is crap. So I'm going to need 6 months to rewrite everything, and then we're good. We're going to ship new stuff. Well, you're going to probably get told off. And if you're not told off, 2 years from then, you're going to still be into this rewriting. So my opinion on this is every chance you get, you just clean your code base. You should try and modernize it, maybe add some tests, modularize it, etc. And you want to do it in as small iterations as possible because you're continuously releasing to production. Or at least that's my life, and I guess it's a lot of yours also. And so that's when local packages come in and can be really useful because they're independent modules, which means there's an enforced separation of concerns. You're going to only make public what you want to make public, and the rest of it, the innards, are going to be just in there, and none of the clients will see it. And that makes them easier to set up, easier to maintain, and it's also a really small initial footprint. That's what I'm going to try and show at the beginning of this, is that you don't need much to start modularizing, and hopefully it's going to help you get into it easily. All right, so a bit of an acknowledgement. I'm going to show you some things that we've been doing at Medium for 2 years. And obviously, it's not just me. It's a whole team of people working at the company right now and people who have been working at the company in the past. And yeah, I'm just thankful that I'm the one who's showing you all of this because I definitely didn't build all of this. So thanks, Thomas. Thanks, Ala. Thanks to the former team, Logan, everyone. Thank you. All right, cool. So what will you expect? So I'm going to have some slides talking about some of the concepts. It's going to be really simple, nothing really advanced. I wanted to keep it day-to-day stuff. And then, because I'm a bit stupid, I'm going to do some live coding, so be nice, and Xcode, be nice also. We'll see how it goes. If you want to follow along, and if the gods of Wi-Fi are nice, you might want to clone this repo, and there are some tags that I'm going to highlight during the presentation that you can follow, but everything will be available at the end anyway. And the idea for this is I wanted it to be less and less familiar. So the first things I'm going to show are probably day-to-day stuff that you know already, and hopefully, till we get to the end, you're going to learn a few stuff. We'll see. So basically, my goal was each of us will leave this room having learned something from my presentation, and that's a lot of pressure. So, okay, did you know that Tim Burton's movie Mars Attacks was inspired by a set of unsettling trading cards from the 60s? They're horrible, and I put in just the nice ones, because I want to show that presentation to my kid at some point. They're horrible. I didn't know about them. We've all learned something. Pressure off. Okay, let's go. So the starting point is, in my opinion, the one that you always get. you just get handed a project. You need to maintain it. You need to release stuff, product features, bug fixes, etc. But you also want to reduce tech debt. You want to make your life easier. You want to modernize the code base. Let's take a look at this project. All right, so simple app. I'm really happy because I got a job at a company that makes dad jokes. And I love dad jokes. So this is just an app listing dad jokes. You have a nice pool to refresh to get some new dad jokes in. And you can fav some of them. And they should all be safe for work, by the way. And then you can remove some of your favorites when you're like tired of reading them. That's it. That's a simple app. But because it's a project that's been on for a few years, the code is like a bit of everything. I'm not going to show you everything that's in there, but basically you have some Objective-C, you have Swift, you have UIKit, you have Swift UI. You have, an okay set of unit tests that are all right. But like, for example, this is the API service. I'm loading everything from the bundle because, again, Wi-Fi. But it's just a fetch of the top rated. You get them. And then there's a bit of Objective-C prefix method in there because I can't use the Swift errors. So people who built this said, OK, we're going to keep some of the clean stuff, and we're going to expose to Objective-C something that works with Objective-C. Whatever, that's how it's done. You have a small design system here, which is just colors exposed in Objective-C. That's used in Swift and Objective-C. It's a bit of everything. OK, so that's the project. You get handed this one. As I said, it's a mix of everything. And you want to put on some sort of strategy to go at it. You just don't want to go into Objective-C code when you have to modify it. You don't want to just like use what's in there. You want to clean it along the way. So the idea for this, or at least what we tried to do at Medium, is we wanted to set up the minimal stuff that we need to have to start modularizing. And I'm going to try and show you this live in a minute. And then you want to do the smallest iterations possible because you want to see them through, including unit tests. You want to take some piece of code, modularize it, and leave it in a state where people after you, your colleagues, or even yourself in a few weeks are going to be able to use it, and you're not going to constrain future iterations on this module. You're going to leave it in a state that's both usable and manageable. And we have a few optional rules. That's actually rules that we use at Medium. Is we don't want to reduce the test coverage, which is always the easiest path, just to remove the tests because you changed everything. We want to always be writing Swift. So that means if you have Objective-C code that works, and you want to leave it there, that's OK. If you want to interact with the Objective-C code, what you write to interact with it should be isolated. You should keep it on the side, and you shouldn't pollute your new Swift code with Objective-C stuff, or like not to the extent that it's going to be everywhere, basically. OK, and so the plan for what we're going to look at today is we're going to set up an initial local SPM package. We're going to see how it interacts with schemes and test targets. We're going to see how the linking is done. Actually, these days with Xcode, things are pretty OK. What I'm going to show you runs on Xcode 14 and supports iOS 14 and higher. So it should be OK. If you're using older versions of Xcode, don't come to me. I don't know how it works. And the first package we're going to do is just take this design system that I showed you, put it in isolation, and then start using it in Swift and Objective-C in the main project. And then we're going to do it with the API service, and this time we're going to try and modernize it a bit. Maybe use some async await, and I'm going to try and show you some cool stuff about using async await in Objective-C. Don't throw anything at me, please. All right, so initial setup. Basically, these days, it's really easy. It's almost one click away to just set some local packages into your project. Xcode takes care of most of it. And the bonus part, if you don't know about it, is that packages, even when you're using them within a project, is just based on the file system structure and the package just with file. So if you're tired of Xcode proj file, XML craziness, XC user data, whatever, you don't have any of this. Well, you have a bit of this, but anyway. All right, cool. So let's try and do this. I have my project in there. And I just want to start with an initial setup so I can modularize some of the stuff. I'm going to go there and just select new package. I'm going to call it local packages, because as you'll see, we'll add different packages in there. And then I just need to find where this moved and put it in the same repository. I don't want to have to play with repositories or anything. Link it to the project, put it at the root of the project. And that's it. That's almost it, but that's it. I have a first package that was created automatically that just has a struct with a hello world. I even have some tests from it. And the nice thing is Xcode created a scheme for me, so I can basically just run the test. Sure, it's going to work. And yes, OK. So that's it. Really, in 2 clicks, I get a local package setup. If I want to start using it, I'm going to take a Swift class because it's easier, and I'm going to just try and print the content of this local package. All seems to work, but obviously, if I try and build this on the right scheme, it won't work. So I'm going to import this package, and obviously, it still won't work, but for a different reason. Now, there's an undefined symbol. That's the only step that you still need to do. That's old school Xcode Pro stuff, is that in these frameworks and libraries and embedded content, you just need to link it. And you'll have to do this for all of the modules that you add. But if I do this, I'm good. Not going to show you the app, but trust me, it works. And all right, so that's the first step. That was simple enough. And now we have our setup. We have a package that does basically nothing, but we can start adding stuff to this setup. So we're going to start with the design system. And basically, it's super easy to add new independent modules these days. They're going to be directly accessible from Swift code in the main project and in modules. And you'll be left with a choice if you have Objective-C code in your project. Either you write your module to be available from Objective-C. You'll have a lot of the Objective-C requirements. You'll have some things that you can't do, like structure items, but you'll be able to do it. We're not going to do this, just because, as I said, we want our module code to be idiomatic Swift and as clean as possible. So let's look at how it might look like. And I'm just going to, no, actually, I'm going to continue on this. Let's try. So how do you add a new independent module in your package setup? Well, it's fairly simple. You're just going to go add a new folder, because as I said, this is just file system. I'm going to call it design system. I'm going to put a new file in it. And again, this is a really stupid design system. It's just a set of colors, making my life easier for the presentation. But yeah, OK. I'm having a design system here. And because it's just file system and package.swift, I'm going to add my new design system as a product of my package setup. I'm going to call it design system. And I'm going to declare a target for it. And this target here will have the name of the folder that I had before. And that's it. With that, and a bit of resolving done by Xcode, I get a design system package. If I had added a test folder with the same name suffixed by test, I would also get for free test set up in the scheme, and I would be able to run some tests. I'm not going to do it here. And let's move on to taking some of these colors. So I want to migrate this one, for example. I want to do it in a really simple way. There's multiple ways to do it, but I want to do it in a really simple way with Swift. So I'm going to just create an enum that I'm going to call colors. And I'm going to put a static var in this enum called accent tint, which is a UI color. And if I remember well, this is system teal. And that's it. I have a set of colors now. Obviously, I want to make this public because everything in your package is internal by default. And so it's not going to be visible in the outside world. And then an easy way to do this is just to say, OK, I'm just going to remove this and let the compiler tell me what I need to do. And obviously, if I'm not on the right scheme, the compiler won't tell me anything. All right, so this was used in Swift. So it's going to be, it should be easy. I'm going to import my package. And here, same thing in there. And get nice autocomplete. Could get nicer autocomplete if I did an extension on UI color, but I wanted to show something a bit different. And I get this undefined symbol again. Obviously, I forgot this one while on stage. Easy enough. I'm going to add it here. Good thing is, these days, the compiler tells you about these things. At some point in the past, you didn't know. But OK, this builds, and I have my first module. It's quite easy because this design system can now evolve and leave, and there can be new stuff in there. It's always going to be there. It's always going to be usable and contained. Now, let's do something a bit more complicated, which is taking one of these colors that is actually used in Objective-C. I know this one is, and I know if I remove it right now, it's going to scream a bit. Yes, it does, in Swift and in Objective-C. And so if I add this here and do exactly the same thing, and I don't remember tertiary system background, and I start using it in the Swift part of the code, obviously it's going to work. I only need to do this because I linked the design system already. But in the Objective-C part, it doesn't. And it doesn't because this is a Swift enum, and none of this is marked Objective-C. So I could do something like this, and add this everywhere. And then because it's an enum, I need to make it a class. And because it's Objective-C, I need to make it NS object. And yeah, OK, cool. That's going to work. I can go in there now. I can import my design system this way. It's visible. Go to where things stopped working. And hopefully, this will work. It doesn't, but whatever. It does, actually. Oh, yeah, OK. That's another one. Sorry. It's just because some quirks of packages, you have to say that this is iOS v14. My project is v14, but package.swift doesn't know that. Be nice, please. OK. I have an issue here, and I don't know how to fix it, but that's all right, because I'm going to move to another tag in a minute. OK, that works. But I don't want to do this. And what I want to show you quickly is we're going to reset everything. And we're going to get to something a little bit different. And this little bit different thing, really? I'm not in the right, sorry. OK, all right. This thing that's a little bit different, it's this. It's what we call a bridge, kind of like the bridges that you have for Objective-C and Swift built in Xcode, but it's something that we built ourselves. And the idea behind this is that I want my design system to stay clean. I want it to stay an enum like this, but I want it to be available in Objective-C when I need it, because I don't want to touch this Objective-C code as long as it works, but I want it to work. So basically what happens is you can remove all of the Objective-C that you have, as long as you're in there, and you're exposing only what you need to Objective-C. The good thing about this is that as soon as you get rid of the Objective-C code, you can get rid of this bridge, and you're fine. That's just a strategy that we've been using, and it's been working pretty well, because then you're left with the Swift code that's nice and clean. All right, cool. Next step is we're going to try and do the same thing with the API service. It's going to be a bit different, because the API service, obviously, it exposes model objects. So we're going to need to have our model objects as modules, and we're going to need to be able to link them. That's simple enough. That's the same package.swift that we saw, except there's two new libraries in there, a model and an API. And if you want your API to see your model, you just do that. Next thing is, yeah, OK, that's a good opportunity to clean all of the things that I showed you before, and maybe move to async await, as we saw in some of the talks during the conference. And so we're going to take this with all of the Objective-C specific code, et cetera, and we want it to look like this. A simple async await. I won't dwell on this. But basically, we're going to go from that amount of code to that amount of code, and something that's a little easier to read. But to do that, because I told you I'm not using any real API in there, and I only have resources, I need to have resources in my package. And again, the way you do it, just to make it clear that it's really simple, is you declare your resources this way. And then you can call bundle.module, which is pretty cool. Bundle.main, bundle.module, easy enough to understand. If you want to talk later about how to use modular resources into your main project, that's something else. But anyway, that's the idea. Last thing is, well, I removed everything that made it available to Objective-C. I put it in a module. I put the resources in a module. How can I get this to be available in Objective-C code? And there's one neat trick for it that we're gonna look at right now. And the idea for this is that if I go to there, I have everything that I showed you. I have my API service in there. That's an async throw function. I have my throw. I can use it as a try await somewhere else. But the actual Objective-C code using it is here, and was using the old stuff with a completion block. I'd like to get access to this. How do I do it? I'm just going to move to the next step. And now I have it. It's named the same way as before, but has a completion handler. And how do I get this? How do I get all of the benefits of async await, but still can use it in my Objective-C code if I don't want to touch it? Well, I built a bridge for the API, and there's nothing in there. Basically, if you're using async await in Swift and you want to use it in Objective-C code, you're going to get a completion handler for free. And that's pretty cool if you still have to deal with Objective-C code. Because that's just the normal auto-completion will take your async await code in Swift and God be nice. Come on. Yeah, this happens. All right. I'm going to try one last time. And then I'm going to go away with this. All right, it's not going to work today. It doesn't want to work. But trust me, this is just this signature turned into Objective-C, which is pretty cool. OK, one last thing that I want to talk about. If you've looked at this and if you've played a bit with interoperability, you probably had some issues like this, cyclic linking issues or cyclic dependency issues. Right now in my project, I have this for one small reason, which is the code that's using the Swift APIs is in Objective-C, but the tests are in Swift. So all of this won't work if I just use it like this. That's some quirks, there are still some quirks in there, but basically what happens is that my Swift code is in a module that gets imported into Objective-C, and then this Objective-C code gets imported into Swift in the test to be able to use it. And so the compiler doesn't know, what do I build first? Do I build the Swift? Do I build the Objective-C? Who needs whom? And that's a cyclic dependency. There's one way to fix it in Objective-C that's a bit ugly, but in my opinion, and my team's opinion, it's all right. Because, again, you don't want to make your Objective-C code better. At this point, either get rid of the Objective-C or tell yourself that your tests are doing the work and you shouldn't take care of it. So basically, what you can do, and that's when you don't throw anything at me, please, is, all right, I get some type checking in my Swift now. I shouldn't, but that's because I removed all information about this Swift code in there. And at least it works. All right, cool. I get to the end of it without most of the thing crashing, so I'm happy about it. What did we cover? We covered how to get a minimal setup. If you're left with anything, just one thing after this talk is it's really easy to start. It's really one click away from starting, and then choose what you move. And as soon as you've moved it, you're going to see that it makes things a lot simpler for you and your team. We've seen how to isolate the code. We've also seen how to bridge it to Objective-C, because trust me, when you get to a big project, you don't want to have all of these at Objective-C stuff everywhere. You want your new code to be clean and just some bridges, because you're still not completely there. You still have Objective-C code. Don't lie, you still have it. And async await bridging to Objective-C was pretty cool also. When we discovered this, we were just to the moon, because it was a pain before that. And hopefully some tips and hints and a strategy for iterative code base modernization that maybe you're going to be able to use. So thank you for listening.
Thank you, Zouhair.
Oui.
So you talked a lot about those packages.
Yeah.
Do you use also a lot of packages in non-legacy code situations?
What do you mean by that? Sorry.
Regular.
Yeah, we actually use a lot of even external packages because it's really easy to set up if it's external or not external. And one thing we've been trying to do, and we're not there yet, is completely remove Cocoa pods in favor of these. As long as they're available, it's all right. Some things we can't do yet, but yeah, we're trying to use packages for basically anything.
How can you manage a project in which you have lots of packages? How do you basically decide who has the right to create new packages in your team, and how can you organize all this?
Yeah. So the good thing at Medium is we're not a really big team, so we don't have a lot of process around these decisions, and we basically try and use common sense when we're reusing something a lot. And when also it would benefit from being isolated, because then as long as when you start isolating things, you're starting to think a bit differently about what it can access, what it cannot access, and what it means. And so when we feel like some piece of code has a meaning by itself, we're going to throw it into a module. And we've been doing this for a year now or something, and never did we tell ourselves this was a bad idea to modularize it. Then there's another strategy that we're doing is that we're having some sort of a hierarchy of modules, and sometimes we're going to do something that's like it's going to have multiple things in there, and at some point we're going to realize that one part of it is getting really big, and we're going to extract it into another module as well, and that worked pretty well for us for now.
How many modules have you got?
I don't know. It's split between two of these local packages that I showed. We have a model one with like 10 packages in there. We have like API, networking, we have some model stuff. And then there's the features, and this one tends to get really big because we have one feature per package. So I'd say around 20.
All right.
Yeah.
And does it have impact on performance, on build performance, and then on startup time?
I don't think we saw any real impact on startup time. It has great impact on performance. It's pretty amazing how it works, and as long as you don't start importing all of your packages into each other and getting really complex with the hierarchy tree, I think it makes things a lot better.
Do you have a dedicated repository for all of those modules?
Nope. Again, the philosophy is we're doing things when we really need them. We never needed this. It's fine for this to live in the repository, and actually modules, kind of by their definition, tend to be pretty small, and so it would be a hassle to just isolate them into repositories. It all lives in the same repository.
Okay.
Fun fact.
Yeah.
The iOS repository is the only repository that lives by itself at Medium. Everything else is in one giant repository, the backend, the front end, the Android app. I hated it at first, but I'm telling it on stage today because I think it's a great idea.
Android developers are used to use packages. So it's kind of Java inheritance. Do you think the iOS community should use more packages, should split more the code?
To be honest, I don't know how much this is used or not. What we found out when we started doing this at Medium is that there was not a lot of real-life experience or return on experience on these things. So that's why I also wanted to talk about it today. So I guess we could do more, but it's also been a hassle for years. When it started, just like Samuel said before, it was really complicated. You couldn't really do whatever you wanted with it. It's getting a lot better. So yeah, I think if you're not on the packages train, you should get on it.
A question from the audience. Actually, I've got a couple. First one being, what's the best strategy to start with? Splitting into different packages when you have a spaghetti code base.
Yeah. So you need to use your good sense to find a piece of the code, even a really small one, that can be extracted. Even if that's why I started with the colors, because it's really stupid. But as soon as you start, and as soon as it gets into your workflow to work on a package, you're going to want to put more things in there. Because I didn't show it a lot, obviously, but when you start working on a package and testing on a package, etc., for example, the refactoring of the API service, you have to imagine that you put all of the code in the package, and then you only work on the package. That means your app doesn't work anymore, but you don't care, because what you're going to do in there is going to compile, you're going to be able to test it, you're going to be able to iterate on it. And so start with something really simple, and don't try and think too much about the architecture of things. Just do a first module, and you'll see the benefits of it pretty quickly, and it's going to become a habit.
All right. And another one is, are there any downsides to what you're shown today?
There are, because I'm praising a lot the separation of concerns, the isolation of the code, etc. But that's one thing you might want to think about when you get to more and more packages, is that those cyclic dependencies, I showed a stupid one, but you can get pretty heavy ones. And you can get yourself into a situation where one of your modules is using another module, but this other module will use another module, and at some point it's going to circle back to the first one. And obviously, that's something that's an issue you'll never have if you have everything in your main project. And so that can be an issue, but usually when you get to this issue, it's because one of the things along the way should be more isolated, or it's not in the right place. So it's also a good reminder that these things are isolated for a reason.
And last question, I guess, how you make sure, I mean, when you have lots of sub-projects and lots of modules, how make sure that all the modules have the same configuration? Like you have to change the configuration to one module, but when you are multi-module, you have to change that configuration everywhere. And how you apply those modifications to all the module, like project-wise?
Yeah.
Let's say xconfig or something like this.
Yeah, but that's the good thing about the modules made with Swift Package Manager is that Swift Package Manager doesn't really care about xconfigs or things like this. At some point, it yelled at me because the platform wasn't set correctly. So I was using something that was iOS 13 without telling Swift Package Manager that I was only iOS 13 or above. But apart from that, if you're used to having multiple xconfigs for multiple schemes or things like this, it's not a concern anymore. And like, if you've used the CocoaPods in the past, or if you're still using it, you always tend to have these config files that are getting bigger and bigger for all of the quirks. And bitcode, that's dead now, I know. I want this in debug, I want this not in debug. The only thing that is a bit complicated these days in setup, if you have an existing project and you start adding modules, is what if I have test files that I want to get exposed outside of this? That's the only thing that's a bit weird in terms of configuration. But apart from that, it's all in the package.swift and the structure of your folders, so it makes your life a lot easier, actually.
OK, thank you very much.
Thank you.
Thank you, Zouhair.